DST sheet we have done around the maximum and minimum element in array, reversing the array, and then the maximum subarray, which was done in our last video. So today we are going to do this contains duplicate. So let's see what the question is saying. We are given an integer nums, return true if the value appears at least twice in the array and return false if every element is distinct. Simple. We just need to return true or false. So let's try this test case. I am able to see that here one is appearing twice. Right here, one at zeroth index and third index. This is going to be quite simple, right? Let's do it from the brute force approach first. For the simple. What I am thinking is about if we sort this array, then it will be something like, let me show you. After sorting, it will be 1, comma, 1, comma, 2, 1, 3, right? 1, 2, 3, 1 will become 1, 1, 2, and 3. So this is our zeroth index, first index, second index, and this is our index number third, right? So this way we can track the duplicates, right? Let's write the solution. So arrays dot right. My given array is nums. So nums is sorted. And now just we need to traverse it from first index to last index and search if we are able to see two consecutive duplicates, same number for that. So let's say where should we start our uh, first index? What should be the first index for traversing the array properly? So we can do one thing. That we can go from zeroth index to second index and keep comparing it with the next index. Like 0 will be compared from 1, 1 will be compared from 2, and 2 will be compared from 3. Or what we can do is we can go from first index to the last index. So the first index will be compared with the zeroth index. Second index will be compared from first index. Similarly, third index will be compared from the previous index. So let's try this second approach, which is I is equals to 1 initially, and then while I is less than nums dot length I plus plus. So our I iterator is going from here to here, and we can compare it with the previous index by I minus 1. So this in this way it will not be going out of bound, right? Yeah. So if bracket nums of I minus 1 now this bracket, sorry, equals to nums of I. So here only we will return true. Otherwise, the iterator will be keep incrementing and it will reach till the end index. And then we will be returning false when it reaches 3. end of the index. I mean, when the for loop is ended, return pass. Okay. That's it. Thanks a lot. This is the brute force approach, right? Here I forgot to add the semicolon. But so running took 0 milliseconds. Let's see it on bigger test cases. So it stays taking 20 milliseconds, and the approach is around n log. So now let's try the brute force, optimal approach. Right. Let's reset this. Oh, fine. So what can we think about the optimal approach? What I am able to see is that this question should require a set because set has only unique values. The property of hash set to data structure which cannot contain duplicates, right? So if we run a for loop, right? Let me show you the hash set. What we'll be doing? We'll be putting elements in the hash set, and if like here we will be putting first one. Before putting, we will be checking if hash set has this set is having set contains this element. First, we will check set contains nums of I, right? If this set has nums of I, then we will return false. I mean true. So quite simple. Let's try this. Hmm. Hmm. Sorry. Let me keep this diagram. I know this is quite messy, but we can adjust a bit. Let me show you the code. So as I said that we will be declaring a hash set. Hash set. It will be hash set of integers, right? Be there. Set. And we will name it set, right? Equals to a new hash, sorry, hash set. So now our data structure has been declared. Let's try to hmm, run the approach. Try our approach, right? Or bracket, sorry, for it's not or bracket. And wait, we can do this using or right or yeah, I is equal to 0. I is less than nums dot length and plus plus. So now we will check if bracket set dot contains I contains I did some mistake. Set dot contains bracket nums of I. We will here only return true that is containing duplicates. Otherwise, we will be adding set dot add. Sorry, add nums of I. I can see that we are going from first index to last index, and we are checking if the set contains none 5 and returning true. Otherwise, we are just adding the array element to the set. When the full loop has been traversed, we will be returning return paths. See, it runs the test cases. So these 10 lines represent this approach. So let's see if it runs or not. So it's passing all the test cases. Same time limit, 0 milliseconds. If you submit it, yeah. So it's been accepted. Now we do not need this diagram. Okay. This is optimal approach. I don't find better than this. Let's move to our next question of the SD sheet, which is this chocolate distribution. Let's see what's this saying. I have solved this earlier. Let's reset this. Yeah. So what's the question saying? Question is saying that we are given an array of positive integers where each value represents the number of chocolates in the packet. Each packet can have variable number of chocolates. Yes. And there are M students. The task is to distribute the chocolate packets among M students such that each student gets exactly one packet. Okay. So each student will be getting only one index, I mean one element from this array. And the difference between maximum number of chocolates given to a student and the minimum number of chocolates given to a student is minimum, and return that minimum possible difference. We need to return the difference between the lucky student and the unlucky student. The student who has got most chocolates and the student who has got least chocolates. Okay, let's try this. So see what we have given it and what should we return. We are going to return an integer, right? And we are given an array list of integers. So first thing which comes to my mind says that we should convert this array list to array, right? Because operations will be quite easier to perform in array. So let's declare int packet equals to in array. It will be not array of integers. It will be in the array of integers. Integer array packet equals to arr.toArray. This is an inbuilt Java function. We will convert this arr to array of integers. After that, what we can do is, since we need to distribute the chocolate such that difference is minimum, so what I think is if we sort this array, then all the elements would be like 1, 3, 4, 7, 5, 3, 4, 7, 9, 9, 9, 1, 4, 9. 12. That- Okay. After sorting, it will look like 1, 3, 4, 7, 9, 9, 12. 3, 4, 7, 9, 9, 12. And the maximum, which is, I forgot to put commas. Otherwise, you will think that it is 1, 2, and 79 or 34, right? So the last element will be maximum, which is 56, which I didn't write. So, okay, there's our error after sorting. And we need to distribute minimum. Each student should get exactly one packet, which means one element should be given to one student from these five students. Each five students will have five different elements, right? The difference between the person student who is getting the maximum chocolate packet and the other student who is getting the minimum chocolate packet should be minimum. So let's try this question. I will not be raising this one. That will be easy for us. Now, integer packet array is equals to array dot to arr, arr dot to array. So we have got an integer array of packet. Now let's sort this arrays. Sort packet packet. Now we have got the packet sorted. Now it says, you can say number of students is 5. We need to run some kind of a mm, sliding window, right? Sliding window which would be going from the first index, taking next four elements. 1, 2, 3, 4, 5. About this much. And another another traversal, another two, it will be going from 3, 4 to this much. Another iteration it will be going from 4, 9, 7 to 12. Another iteration, this sliding window will be keep moving from here to here. 7, 9, 9, 12, and 56. Beyond this, it will be not going. Let me only keep only one window for you. So that will be easy for visualizing. Let's solve the question. Hmm. Let's see. So see what we can do. Let's put in left index is equals to 0. And if left is 0, or right should go from 0, we will be adding 0, 1, 2, 3, 4. Yeah. Number of students minus 1. M minus 1. Now we can write the solution right bracket. Our R is less than V is bracket dot left less than. Hmm. Our right array is going from here to here. Now, yeah, first We need to also declare another difference. And difference equals to, initially let's keep it 0. We need to minimize the distance. So let's keep it the last index of the array. Our difference, let's keep it in smaller variable. If how we will be minimizing this one. If equals to add one of if well, R minus L. So difference will be maximum at this point, and R will be here. Yes. And L will be here. Okay, why this is okay. And after this is 10, we will be updating L plus plus R plus plus. In this way, the window size will be fixed to M. It will not be greater than M or less than M, since we are updating L and R similarly and at the same time in the same loop. Now let's try to return this diff. Now, our diff is an integer and it wants an integer. Sure, but let's try run this. I mean run this. Saying something. Yeah. So you are missing here. This line is causing error because saying that object cannot be converted to integer. Oh, I found that you can do it using. We have not used no integer. How should be accepted? First test case is running. Let's submit this solution. It has done everything. Time taken is 1 second. Accuracy is 100%. So this much was about today's video. Thank you.